This is Foundations in Pre-Cal 10, Lesson 1.5, which is Integral Exponents. Uh, it says Part A starts on page 35. There's only one lesson, one video for this lesson, so it's a little bit longer than I like it to be, but we need to, there's a lot of, that's all new stuff, and we need to sort of go through it in one chunk. Okay, so we're going to start with introducing a negative exponent and what does that mean and how do we know? So what we're going to do is we're going to look at this pattern here. So if I have 10 cubed and I am just going down the column here, if you notice that on the left side the exponent is going down by 1. So I've got subtracting 1 with the exponent, minus 1. So 2 to 1 to 0, -1, -2, -3. The exponent is going down by 1 every time. And on this side, I'm dividing by 10. Okay, so I divide by 10, I get 100. If I divide by 10, I get 1. If I divide by 10, I get 1 over 10. I divide that by 10, I get 1 over 100. And I divide that by 10, I get 1 over 1000. So far, so good, right? I just want to pause and point out that anything to the power of 1 is itself. That's one of those rules that you should know. You need to know that. And anything to the 0, to the power of 0, equals 1. Those are always true, as long as your base isn't 0, but we won't give you that. And then I want you to take a look at this. I've got 1 over 10, which can also be written as 1 over 10 to the power of 1, because they're the same thing, right? And then 1 over 100, I can write that as 1 over 10 squared. And 1 over 1,000, I can write as 1 over 10 cubed, because 10 cubed is 1,000. So that's that one. Now let's look at the power of 3. So again, our exponent is going down by 1 on the left column, the left side of the equal sign, and on the right side, we're dividing by 3. So 27 divided by 3 is 9, divided by 3 is 3, 3 divided by 3 is 1. So again, 3 to the 1 is 3, and 3 to the 0 is 1. Those are those 1 and 0 rules. Then if I divide this by 3, I get 1 over 3. And then I divide that by 3, I get 1 over 9. And I divide that by 3, I get 1 over 27. And then I can write 1 over 3, that is 1 over 3 to the power of 1. And 1 over 9 is 1 over 3 squared. And 1 over 27 is 1 over 3 cubed. So what I want you to notice here is that when we have a negative exponent, we just move it into the basement and we change it to a positive exponent. The number, like the absolute value of it stays the same. Like if it was a -1, it becomes a 1. If it's a -2, it becomes 2. -3, it becomes 3. So then the number, the absolute value of it stays the same. So the sign changes when you move it into the bottom, okay? So let's look at this, the general, with just a variable. So anything to the 0 is 1. Something to the -1 is 1 over the something. Whoops, 1 over the something. A to the -2 is 1 over a squared. A to the -3 is 1 over a cubed. So I moved it into the denominator and I changed the sign of the exponent, okay? Let's write these with positive exponents. So 10 to the -7, that is equivalent to 1 over 10 to the 7. 3 to the -5 equals 1 over 3 to the 5. A to the -10 A to the -9 equals 1 over a to the n. So I just changed the sign and moved it to the denominator. All right, let's show that this is true in another way. Let's consider 5 to the power of 4 divided by 5 to the power of 7. So if I use my calculator to figure out what this equals, it comes out to 0.008. And I want you to just make sure that you get that with your calculator. It is important that you can functionally use your calculator. Although you're not going to be allowed to use your calculator for this test, you'll not your exponent calculator, but you will get a calculator. I'll talk about that in class. we're going to be using exponents for the rest of the year and the rest of your math career. And you will be able to do this on the calculator if you need an exact value for them. Okay. Okay, so let's evaluate this using expanded notation. So we have 5 times 5 times 5 on the top, and in the bottom we need 5 times 5 times 5 times 5 times 5 times 5 times 5. So I have 7 of them on the bottom. And then I can cancel some of them out. I can go top divided by 5 is 1, 5 is 1. So those cancel, these cancel, these cancel, these cancel. Now it's really important that you realize that I do not have 0 in the numerator. I have 1 because what I've really done is said 5 divided by 5 is 1 and 5 divided by 5 is 1, and then I just said 1 times 1 times 1 times 1 on the top. But we're usually lazy and we just cross them out. But there is a 1 there. There has to be something as a placeholder. What I'm left with is 5 to the power of 3. Okay, so if I evaluate, that's going to be 1 over 125, which, lo and behold, my calculator tells me is 0.008. Yay! Now, of course, we don't want to always write it out like that. You know, if it was 5 to the 712 divided by 5 to the 603, I don't know about you, but I would absolutely get that wrong if I tried to do it this way. So we use the quotient law instead. And the quotient law doesn't matter if you have negative exponents, okay? You just follow the same thing. When you divide powers that have the same base, you subtract the exponents. So 5 to the 4 divided by 5 to the 7 is 5 to the 4 minus 7, which is 5 to the negative 3, okay? Which equals 1 over 5 cubed. Okay, you will usually be asked to leave it with no negatives. That's just one of those conventions, like we always reduce our fractions fully. We generally leave exponents with positive, or leave powers with positive exponents rather than negative exponents. All right, these parts show the general rule, which is if we have a to the negative p, that equals 1 over a to the positive p. And we're going to write these with positive exponents and then evaluate. So 2 to the negative 1 equals 1 over 2. I would just leave that as a fraction. I didn't actually check what your answer key does, if it's looking for a fraction or a decimal, but you should check that when you're marking your work and provide whatever it's asking for. 3 to the negative 2 is 1 over 3 squared, which is 1 over 9. I really, really, really recommend that you do write this step and don't try and do this in one, like don't try to go from this to the 1 over 9 in a single step. It's not worth it. It's not worth having to juggle it in your brain and you're moving things and you're changing them. Going from the 3 to the negative 2 to the 1 over 3 squared is going to help you remember what the rule is. If you just like do not be pulling out your calculator to get it. You need to be able to do this without without using the exponent button on your calculator. The purpose of this is for you to figure out and understand how to work with the exponent rules. Okay. All right, and then this is 4 to the negative 3 is going to be 1 over 4 cubed, and 4 cubed is 64. So that's 1 over 64. All right, that's one page down, 1.5 to go. No, 2 more to go. All right, next page. Okay, the negative exponent in the denominator. So let's use the rule for division of fractions to show this. So if I have 1 over 4 to the negative 3, that equals 1 divided by 4 to the negative 3, which equals 1 divided by 1 over 4 cubed, because now I'm taking my 4 to the negative 3 and writing it with a positive exponent. So that equals 1 times 4 cubed over 1, which equals 4 cubed. Cool. Okay. And then 4 cubed equals 64. So use your calculator to confirm. So make sure that you can put this in your calculator and get 64 as your answer. And if you can't, make sure that you're asking for some help. Okay. Okay, so we already looked at this first part of the rule, where if we have a to the negative n, it becomes 1 over a to the n. And it works the other way as well. If we have a negative exponent in the denominator, we can move it into the numerator and it becomes positive. Okay, so either way works. All right. Simplify, express with positive exponents, and evaluate without using a calculator. So um, this becomes, I'm going to use the exponent rules because that's the more efficient way of doing this, of course. So this becomes 4 to the power of 5 plus negative 3, which, because I'm multiplying powers with the same base, I add the exponent. So that becomes 5 minus 3, which is 2, which equals 16. I should be able to do that without a calculator. This is, again, I'm multiplying, so I'm going to add exponents. So this becomes 3 to the 2 plus negative 5 equals 3 to the negative 3, which is 1 over 3 cubed, which is 1 over 27. I've got a negative exponent in the bottom, so I'm gonna flip that into the top, so that becomes 2 to the 5. It's actually 2 to the 5 over 1, but we don't bother with the over 1 part. And 2 to the power 5 equals 32. There's two ways that I could do this. I could go, this becomes, since I'm dividing, I'm going to subtract my exponents, right? So this is 6 to the negative 7 minus negative 5. That seems dodgy, doesn't it? So that's 6 to the minus 7 plus 5 equals 6 to the negative 2, which is 1 over 6 squared, which is 1 over 36. So that's one way to do it. Another way I might do it, um, my inclination is always to get rid of my, if I'm working in fractions, to get rid of my negative exponents. So I would move the 6 to the negative 5 up to the numerator, make it positive, and move to the 6 to the negative 7 into the denominator and then make it negative. And then I'm just looking at that, and I'm not really thinking about the subtracting it rule. I'm thinking more about if I expand this out with all the sixes I have and expand the denominator with all the sixes I have, I can see that I'm just going to have 2 on the bottom when I cancel everything out. So that becomes 1 over 36. So whichever way is going to work for you, that's just fine. Okay. For this last question, it's 2 cubed to the negative 1. There's you can, the weird thing with exponents is there's really quite a few ways that you can do this. If you follow the power rules, where you multiply those powers, you get 2 to the negative 3, which is then 1 over 2 cubed, which is 1 over 8. Okay, and that's the way we're going to do it today because we haven't, have we done that other rule? We have, yeah, let's just leave it with that. Okay. Okay, example 2. This is true. This is false. This one is a little bit tricky because you need to, in order to do this, you need to change everything to the same base. So the way you would do that is, here, I'm just going to, let me put the false up there and then erase this and rewrite it a little bit. So we've got 8 cubed. Well, I can write 8 as 2 cubed, and then it's all cubed. And 4 to the negative 1 is 2 squared because 4 equals 2 squared, and that's to the negative 1. Okay, and then that would be 2 cubed times, sorry, that would be 2 to the 9, right? That's, sorry, oops. So this is 2 to the 9 over 2 to the negative 2, which is going to be 2 to the 9 times 2 squared, which equals 2 to the 11, which is definitely not equal to 2 to the power 4. Okay, so that's definitely false. Okay, and then this one here, that is true, right? That's just the rule. I'm taking a negative exponent, moving it to the denominator and making it positive. It becomes positive. Okay. Explain why 2p to the negative 3 does not equal 1 over 2p cubed. Pause for a moment, take a look at that. So the rule that's applying here is like the number one rule on my list, which is the exponent only affects what it's touching. I think it's supposed to be affects. I'm not sure. It's touching. And that's really important because this negative 3 is only touching the p. It is not touching the 2. So 2p to the negative 3 is 2 over p cubed, right? Because the negative 3 is only affecting the p. Okay? So there you go. One more page. I know this is a long video, but let's do this. So we're just going to simplify this. So this is going to be, we're multiplying powers, so we're going to add exponents. So this equals a to the negative 4 plus negative 3, which is a to the negative 7, which is 1 over a to the 7. Remember last year when your teacher probably told you over and over and over again that exponents or integers, being able to work with integers is really important? Well, it's true. We use them all the time. The other way you could do this is you could write this as 1 over a to the 4 times 1 over a cubed. And then when you multiply fractions, you just multiply the numerators, multiply the denominators. So this becomes 1 times 1 over a to the 4, a to the 7, which is, sorry, a cubed, which is still equal to 1 over a to the 7. So either way is good. If I ever see something written with a division sign, I almost always rewrite it as a fraction. Believe it or not, that actually becomes easier. So we got 6x squared over 2x to the 7, and then 6 over 2 becomes 3, and then when I've got x squared in the top and x to the 7 in the bottom, I'm again picturing if I cancel 2 to get rid of the numerator, I'm taking 2 away from the denominator, and I'm left with x to the 5 in the denominator. This one, I'm going to, I want to get rid of my negative exponent, so I'm going to move the y to the negative 5 up. So this is going to become y to the 6 times y to the 5 over 2, which is then y to the 6 plus 5 is 11. So y to the 11 over 2. This is to the negative 3. I'm going to write this as 1 over negative 2x cubed because this exponent is touching the brackets, so everything in the brackets gets moved to the bottom. Notice that the sign here does not change. It's only the sign in the exponent that changes, okay? And then this is going to be 1 over negative 2 cubed times x cubed. So that's going to be 1 over negative 8x cubed, which we would normally write as negative 1 over 8x cubed. We tend to float the negative up. But it's not wrong with the exponent in the bottom. We just tend to look for it in the top. Okay, I can simplify the 8 over 4. That becomes 2. I'm going to move my b cubed up, and I'm going to make it positive. I'm going to move my a to the negative 5 down and make it positive. So there we go. And this one, again, this exponent, the -2, is affecting the whole thing. Hi, Kitty. So this is going to become, if I move that down, I have to keep my 1 in the numerator, right? There has to be something up there. So this is going to be 5p all squared times 5q to the 4. Now, it doesn't matter whether I, sorry, my cat's come for a visit. Go away. It doesn't matter whether I put the P or the Q first, or what's on top first, or whatever, but we tend to look for things to be in alphabetical order, so I'm putting the P first, okay? Now I'm going to expand this part, so 5 squared is going to be 1 over 25p squared times 5q to the 4. Again, don't try and do it all in one step. You're just so much more likely to make a mistake. Didn't take long to write that. It takes longer to talk about it. Now I'm going to combine or multiply and simplify this. So 25 times 5 is 125. P squared q to the 4. All right. Simplifying a fractional base with a negative exponent. So let's work through this. We've got 2 over 3 to the power of -4. And so I can make that, I can move the whole thing to the denominator, or move it to the denominator, right? Make it 1 over 2 over 3 to the 4. My exponent is now positive. So that makes it 1 divided by, and I'm going to write this, sort of expand this, is going to be 2 to the 4 over 3 to the 4. So now I'm going 1 divided by this fraction, which becomes 1 times the reciprocal of that. So this becomes 1 times 3 to the 4 over 2 to the 4. So I've just flipped that fraction. And that equals 3 to the 4 over 2 to the 4, which equals 3 over 2 to the power of 4. So they want us to evaluate this. So 3 to the power of 4 is 81, and 2 to the power of 4 is 16. And then we're going to classify this as true or false. Is 2 over 3 to the -4 the same as 3 over 2 to the 4? Yes, it is. That's what we got up here. Okay. So the rule is you flip the fraction, and then you make the exponent becomes positive. Okay. And that's actually what we were doing back back on this page. Where were we? That's actually what we were doing. We were actually doing that here, because you could think of a to the -2 as a to the -2 over 1. Now it's a fraction, and you're just flipping the fraction. Fractions are scary, so we don't mention them until we have to. So what's a quick way to evaluate 5 to the -3, or sorry, 5 over 2 all to the -3 without a calculator? Well, you flip it, you make it 2 over 5 all cubed. And then 2 cubed is 8, and 5 cubed is 125. So there you go, done, no calculator needed. Okay, so this is the general form of the rule. A over B all to the -n equals B over A all to the n, as long as neither A nor B is 0, because you can never divide by 0 or the universe implodes. Oh, I forgot to put that this is true up here. Okay, that is the end of it. Go and do assignment, all the questions 1 to 15, and we're done with this lesson. Bye.